Hello everyone, here in this video. In today's video we are going to talk about one of the four fundamental forces in universe, the gravity. In this video we will see what actually gravity is, who was the scientist in ancient time, who started studying about gravity, and the most accepted theory of gravitation. Let's start this discussion from very early ancient times. The motion of celestial bodies such as the moon, the earth, and all stars and planets has been a subject of great interest for a long time. Famous Indian astronomer and mathematician Aryabhata studied this motion of celestial bodies in great detail, most likely in 5th century AD. He established that Earth revolves about its own axis. He also gave description of motion of other celestial bodies as seen from the Earth. Aryabhata was the first who gave the description on this topic and studied in detail. About 1,000 years after Aryabhata, two scientists named Tycho Brahe and Johannes Kepler studies the motion of planets in great detail. Kepler formulated his important finding in his 3 laws of planetary motion. The first law is, all planets move in elliptical orbits with the sun at a focus. The second law is, the radius vector from the sun to the planet sweeps equal area in equal time. And the third law is, the square of the time period of a planet is proportional to the cube of the semi-major axis of the ellipse. This was all about the motion of planets. But we are still unknown to the theory of gravity. Then after the Kepler's law of planetary motion, the great mathematician Sir Isaac Newton noticed that the falling off apple towards the earth. After that he assumed that Earth attracts all heavenly bodies towards its center. Then he started searching for the question that, what is the law which governing this force? After making observations, experiments, and calculations, he declared that the law of nature are the same for earthly and celestial bodies. Then he kept working on this and stated that force of the gravity is directly proportional to the product of those two bodies in between, the gravitational force we are measuring, and it is inversely proportional to the square of the distance between those two bodies. Then after he removed the proportionality sign and formed the equation F is equals to G into m1 into m2 upon r squared, here the G is said to be universal constant of gravitation. Newton further generalized the law by saying that not only the Earth but all material bodies in the universe attracts each other according to the equation given by him with the same value of G. The constant G is called universal gravitational constant, and its value is found to be 6.67 times 10 raised to the power -11 Newton-meter squared upon kilograms squared. The theory of gravitation was stated by Newton in early 17th century. At that time it was considered the most accurate theory of gravity. Now let we see the one question which probably proved the Newton wrong about his theory of universal gravitation. The question is, if the force of gravity is directly proportional to the object's mass, then why the massless light is get affected by the gravitational field of the black. Now answer to this question is the simple guess I made. That is, the source of gravity is not mass, it is energy and momentum, which light certainly has, and also the regular matter has too. So that the light get affected by the gravitational force of the black holes because of their energy and momentum, not because their mass, which it has not to it. So that not only black holes affects light, does stars and planets also affect the light. Newton's theory has some limitations. It is very well applicable to Moon, our nearest planets, and our solar system. It becomes only the approximation above that. Also it is negligible on Earth and it can't be measured in quantum field. Then after in 1905 Albert Einstein came with his theory of relativity. This theory describes gravity as the distortion of space and time which bends and stretches because of mass of the celestial objects like stars and planets. After few years later we started learning about the quantum physics. Not everything, but we gained some awareness of the confusing world of quantum physics. Then physicists discovered the existence of very small particles which were later found to affect even biggest, most powerful phenomena in the universe. This led to the discovery of force carrier particles behind 3 of the fundamental forces which are governing the universe. The electromagnetic fields has photons, the strong nuclear force has gluons, and the weak nuclear force is carried by W and Z bosons. These leaves the gravity odd one out. Then after physicists hypothesized that if the another three fundamental forces has a corresponding quantum theory, then there must be a particle behind the gravity too. Then after an attempt to relate the gravity with the quantum theory, physicists came up with the hypothetical particle known as the graviton. The graviton is said to be massless particle that travels at the speed of light. The graviton remains hypothetical, however, because at the moment it's impossible to detect. Because at normal scale the gravitational force is negligible. So that this particle has not been found yet. Science itself is the biggest mystery, and we are still exploring it. So thanks for watching. We are coming with more amazing videos like this in future. So do you like this video, don't forget to like this video and subscribe to our channel.